Hey 45 Drive subscribers, welcome back to another weekly tech tip. Today it's tutorial time. So what we're going to do today is run through the process of configuring and setting up an iSCSI target server on Ubuntu Linux, and we'll get some help from Houston UI as well. So let's jump into it. All right, so before we start the actual tutorial, we're going to talk a little bit about what iSCSI is. So 45 Drives is best well known for our NAS storage, so our network attached storage. What that is mostly file system based storage where you share out file systems to multiple users. iSCSI is very different. It's built for block storage, so no file system, and it's used for getting storage out to many different services or applications. So if you have hypervisors or multiple servers that do different duties in your infrastructure, you may have a SAN, which is a storage area network, which is just a collection of hard disks that are grouped up and are able to be shared over the network as such. So iSCSI is what facilitates that. So iSCSI, SCSI is just small computer system interfaces, and I is because it's over the network. Now before iSCSI, there was Fiber Channel. And this was its own dedicated protocol. It didn't run over TCP/IP, had its own switching, had its own HBA cards. So it is quite expensive, but it was great in the early going before networking really caught up to like the throughput of what Fiber Channel could do. But nowadays, networking is very fast, and you can get very low latency networking as well. So iSCSI really is, in a lot of cases, the best way to go, depending on how you configure it. Another thing to consider too about iSCSI or block-based storage protocols over the network rather than file system based is that the locking happens at the client level or the user that's actually using it. Whereas with our NAS, the locking usually happens at the file system or the Samba layer. So that means you have to be very careful in how you configure and manage your iSCSI devices, because if two clients essentially map the same block storage, they don't know anything about each other, and they can start writing to the same blocks, which would cause corruption immediately. So if you don't configure it correctly and you make some mistakes, it is very possible for that to happen. Whereas with a file system, the actual file system is aware of all of that. And so if someone opens a file, it's going to lock that file so it can't be corrupted or opened by another user. So you have to be very careful to configure this correctly and just understanding the environment. So with that being said, let's jump into the tutorial. I'm going to show you the configuration and setting it all up. Okay guys, so we have our iSCSI test environment up here. So for anyone following along, this is an Ubuntu Linux client. This is actually just a virtual machine, but you can do it with a virtual machine or a bare metal machine. So there are some prerequisites. This does have some things changed from a normal vanilla Ubuntu Linux install. I'll put the script that you can run in the description of this guide, and it essentially changes some things that vanilla Ubuntu would use. Like for example, we're using Firewall CMD and we're using Network Manager for our Ubuntu, whereas vanilla Ubuntu wouldn't use that. So just some things like that. And also what it does is it installs and gets your cockpit and your Houston UI up and running as well. So I'll link that script down below. Potentially if this is a server that's already in use that you've already got up and running, be careful to run that script obviously, because it may change some things for you. But other than that, let's get started. So we can see we have our iSCSI demo server here and we have our Houston UI up. So this guide is going to go through the whole process. We do have a ZFS pool here created already. We don't have any data sets, so we're going to actually start from there. So I've got a ZFS pool created, and what we're now going to do is create a data set. Now I can already hear the comments because we're going to do things a little differently from what you may expect with ZFS and iSCSI. Maybe a little controversial, but the testing we have done as well as the research we've done as well shows that using actual sparse images in file I/O is a little bit faster than ZVols, and ZVols can come with some other problems as well. So while ZVols are great if you've got to use a legacy file system with your ZFS and still get all those great things that ZFS brings, like the snapshots, the copy on write, and all that, it's great. For this use case, we prefer using images. So what we'll do is we'll create a data store called images, and that's where we're going to create our file I/O raw images for iSCSI. So let's start there. We're going to create our file system called images, and everything else can be just set standard here. So there we go. We've got our Z pool called tank, and we've got a data set called images. From there, we can pop on over to our terminal. And first things first, we're going to want to actually install iSCSI because it's not installed by default. So let's go apt install target CLI-FB and chuck a Y in there so we do it automatically. So once this finishes installing and we get everything configured, we're actually going to enable some of the processes within Houston UI, but we'll save that for a little later. All right, so the next step, we're actually going to move into that images data set that we created. So we'll go cd/tank images. Now, the really cool thing about this is if you have different types of workloads or different performance tiers that you need, you can create a different data set with a different record size for each of your images. If you're using a zvol and you're hooking this into iSCSI, for example, you have to choose a block size of either 512 or 4K. Otherwise, VMware will not accept it. So using images allows you to use record sizes of different data sets, which is kind of cool. So this data set is using 128 kilobyte record size by default, and we're just going to leave that for now, which is pretty good for if you've got large streaming writes into this thing and reads. But depending on the workload, obviously some virtualized workloads are going to be more IOPS focused and things like that, and we may have to change the record size depending on the image we're using. But it's very, very flexible. We just need to create a new data set and then create a new file within that data set. So the next thing we're going to do is we're going to create a sparse file. You can do this in Target CLI, but it takes much, much longer because Target CLI is actually going to zero that file. So if you're doing very large images like 50 terabytes and beyond, it could take days. Whereas if you just actually create a sparse image ahead of time and then plug it into Target CLI or iSCSI, it'll happen much, much faster. So let's do that right now. We'll create a very quick image. And first, let me actually see how much space we have. All right, so we've got 111 gigabytes available. So let's just create a 100 gigabyte file. So let's go dd input file is just dev0. Our output file is just going to be the name of our image that we're reading. Let's just call it lun0. We're going to byte size 1 because we have to set something, and we'll set the count to 0. And we want this to be 100 gig. And you see how instantly that happens. So even if you do this with 50 terabytes, 100 terabytes, it will be just that quick because it's not actually creating those files or a file that large. It's just creating the markers for those files. So now if we take a look, we now have a 100 gig sparse file called lun0. So now that we have Target CLI installed, let's pop over on into it. So the first thing we're going to do is we're going to add that image we just created. And normally if we were using zvols, we would go into block. But because we're using an image file, we're going to go to File IO. So once you're in File IO, we're now going to create that backstore. And and there we go. So we've created our image of 100 gigabytes. And if we take a look back here and we had an ls, we can see that lun0 is there. So that puts the lun into iSCSI itself, but now it has to actually be mapped to an ACL, to a client that we're going to use. So for this testing purposes, what we're going to do is we are going to use my vSphere environment. But before they do that, let's just actually create our iSCSI target itself. So we go down to iSCSI, and we're going to create our new target. So you do create and our IQN, and let's say 2021-04 is the month. Then you just use reverse DNS naming here. So .com.45lab.iSCSI demo. And then from there, we'll just give it a unique name. Let's say demo1. There we go. So we've now created our iSCSI target, and we can actually see by default what it will do is it will create portals listening on all of the IP addresses that this node has. So we're going to want to change that if we're going to do multipath IO, and also just for best practices. This is going to allow iSCSI to be shared out on all IP addresses that you have, which is not best practice. You want to limit that to your own iSCSI networks. So the next thing we're going to do now is actually create the ACL, which is where that vSphere environment comes in that I was talking about. We'll grab the IQN of the vSphere environment itself, and we're going to add that as an ACL. So that's essentially allowing the VMware vSphere environment to communicate with our iSCSI target. So we go to ACLs, but first let's go on over to one of our nodes. Let's use 23 for this one. We go into configure, check our storage adapters, and if we take a look right down here, we can see the IQN name. So this is exactly what we need, and this is the ACL name we're going to give it. All right, so next step, we're going to create that ACL. And there we go. So now it's been created. Now we're going to add the backstore that we created in File.io to this machine. So in order to do that, it's as simple as typing create, and it'll just tab finish for you if you want. And you can see it's in backstores, File.io, and LUN0. So there we go. So that LUN is now easy and ready to be shared out to its actual initiators or its clients, which is, in this case, vSphere here on 150.23. But before we do that, we have some more things as well that we're going to do. So what you could do is you can add authentication to this. So if you wanted to lock it down with passwords and things like that, you can do that. And actually, that will be in the guide that I'm going to link in the description below. But beyond that, let's just leave this one wide open, but let's do some extra configurations that we're going to need to do. So first, let's exit our iSCSI, and let's clear this and take a look at our IPs. So we can see here we have ENS18, which is the IP address of this machine that we were accessing here. But now we're going to create two iSCSI interfaces. They're going to be set up for multipath I/O. You don't have to do this, as I said. You can set one single path and share that out, especially if you're just mapping disks to your Windows environment, or you're just testing this out. It doesn't have to be using two different subnets. It doesn't have to be set up with multipath. But for a production environment, this is definitely something you're going to want to consider, is setting up two different subnets for your iSCSI. So that's what we're going to do very, very quickly right now. So we'll go into our NMTUI, and we're going to edit the IP addresses of 19 and 20. So this one is going to be on the 10.10.2 network, and /95 is the IP. And we'll hit to automatically connect. And then we'll use 20 to use the 10.10.3 network. Okay. Now that's all it should take. We can quit out of this and see if it worked. All right, so we can see our 19 and our 20 is up. So just to make sure that this is working, let's ping an IP on that network. Looks like 2 is working, so let's try with 3. So sorry about that, guys. Mid-filming, my wireless keyboard decided to die, so we had to switch the batteries out. But back to what I was saying. So first, let's make sure that we can communicate and the 2 network is working correctly. And there we go. So we can see we're getting a response from another IP on this network. And let's also make sure the 3 network is working as well. And it is. So this iSCSI, this network that we're using, or these 2 networks that we're using, is actually an iSCSI designated. Both are iSCSI designated subnets. So that's what they're being used for, and nothing else. And this is just a new iSCSI server that's using this same subnet range for testing. Okay, so now we've got those 2 IPs up. So let's go back into Target CLI, and let's get rid of that mapping to all of the actual interfaces. So Target CLI, now we move down to our portals. We can see we have 0000 set, so let's remove that. Delete 0.0.0.0, 3260. There we go. So now we're going to create our 2 paths. Create 10.10.2 2.95, and we're going to use 3260, the standard iSCSI port. And we'll do the same thing for the 3 subnet. So there we go. So now I'm going to go up to the top and we'll just list this out so we can get a look at this. So there we go. So we have our backstore set up. We have our file IO LUN is created and mapped. And now we have our actual IQN for our iSCSI target. In that target, we have an ACL created, which is our client, which is the VMware ESXi server. And on that ACL, we have one mapped LUN, and it's the same LUN that we have up here. And then if we go down and we look at our portals, we can see we have 2 interfaces that are sharing out iSCSI, which can be used for multipath I/O. So there's different ways that you can set up and do multipath iSCSI, but if you remember from the intro when I talked about how locking happens at the client side and not at the actual server side, very, very similar. So multipathing and how that's handled will be handled upstream at the actual client who's using it. So all we do is we give the different IPs available for multipathing, and then the initiator or the client will be the one to set up how that works. And we're going to show that very soon. So this is ready to go and it's configured. So now we're going to exit and save. So now before we continue, we have a few housekeeping things that we need to take care of, and we can do this from Houston UI. So again, this is a VM, so if we click on why this is saying we have some failed services, it's just due to IPMI, and we don't have IPMI set up on a VM clearly. So the 2 things we need to do here from Houston UI, the first one is to enable and start our iSCSI service. So if we come down to services and we go to system services, we now have to search. So if you search RTS, and now we can already see it. We have our target CTL. We need to turn this on and enable it. So we can see we're going to start and enable that service. So now at restart and reboot, this machine is always going to restart the target CLI or the iSCSI services. And the next thing we need to do is open up that firewall port. Now again, in a vanilla Ubuntu install, it uses UFW, not firewall D, and even by default, I don't believe it's actually enabled, so you may be able to skip this step if you're not using a firewall or you don't know if you're using a firewall. So we're just going to add a new service into our firewall. So let's click on our active zone, and let's add a service. So again, we're just going to type in iSCSI, and we can see 3260, that same port that we're using, and let's add that service. So that's now ready to go. And we can see it's up and it's saved. Perfect. So now our iSCSI target, our iSCSI server, is ready to begin being used by the clients. Okay guys, so let's take a look and see if we can get this to show up on our ESXi server. So we're on our host 23, which we used for our ACL. So now let's go and see if we can discover that LUN from our IQN. So all we need to do is put in one of the IP addresses, and it should be able to find the other one. So let's use 10.10.2.95, and it should automatically find 10.10.3.95 for us. So we're inheriting authentication settings because we're not using any passwords or anything. That's fine. Now the next step, you click on your iSCSI adapter and you rescan. Actually, this is a good time while we're waiting for the adapter to rescan to talk about iSCSI adapters and what they are. So when I talked a little bit about fiber channel earlier, you literally have to have a HBA that is fiber channel enabled on your servers that you're using in order to use fiber channel. iSCSI is a little cooler because it is over a TCP/IP network. Regular networking cards can facilitate that, but there is dedicated actual iSCSI cards that you can get that kind of take some of the workload off the CPU. But normally what you're going to use is just a regular software adapter, and that's what we're using here in our iSCSI on our ESXi host, is just a built-in software adapter where all these commands are handled on the CPU itself. So now we can see that it has done its rescan. So if we pop over on static discovery, we should now see, and which we do. So we use 2.95, it found 3.95, and we can now see the IQN is showing up. Our 45 lab iSCSI demo and demo 1 IQN is there. So now if we rescan the storage as well, we don't have to scan for VMFS. So let's rescan that storage and pop over to the storage devices. We should see a 100 gigabyte, and here we go. There it is. So we have a 100 gigabyte iSCSI LUN that is now able to be attached. And we can see it's not consumed, and this is a regular LIO iSCSI disk. We have some other Petasan iSCSI disks for our clustering offering, but this is the one that we just created, that we just mapped. Now, if you are to use multipathing in any reasonable way, we can see by default multipathing's on, but iSCSI uses what's called most recently used by default. So if we look at the paths, we can see both paths are here, but only one is being used for I/O. We can easily change that by editing our multipathing and dropping down to use round robin. And as soon as you do that, what that's now going to do is it's going to use both paths for your I/O back and forth, which is always a great thing. So there we go. So if we click back on it, we can see here now, if we click on our paths, we can now see both paths are showing up as active and both using I/O. So that was the tutorial. If you want to map one of these iSCSI LUNs in a Windows environment, it is very, very simple, and it's actually going to be included in that guide that I'm linking down below. So if you don't have an iSCSI environment or anything like that, and you just want to try this out on a Windows machine just to get your skills up or to learn it, that will be in the guide, so we'll show you how to do that. All right, guys, well, thanks for watching the tutorial. Hopefully you learned something useful. If you have any questions or want to see something in a future video, please don't hesitate, leave it in the comments down below, and we'll definitely get back to you. If we don't make a video, we'll at least respond to you and try to give you as best information as we can. With that being said, thanks for watching, guys. We'll see you on the next one.